Here's a question from our lab assignment, section 5.1. It says here, when we estimate the distance from velocity data, it's sometimes necessary to use times t1, t0, t1, t2, etc. that are not equally spaced. So we might get used to collecting times and information where it's equally spaced, but sometimes it's not the case that we're going to be able to have that. We can still estimate the distance using the different periods, delta t sub I, which is the difference between the t sub I term and then the term before that. For example, a space shuttle was launched in a mission, and the purpose of which was to install a new motor in the satellite. This table provides the table provided gives us the velocity data for the shuttle between liftoff and this jetting of the solid rocket boosters. So use the data to estimate the height above the Earth's surface within the 62 seconds that's given after liftoff. So if we take a look at the data set here, again, it's typed up in Desmos. It's hard to see this because it goes all the way up to 41. Actually, they said they just want to go up to 62 seconds. So maybe let's go up this high, and I guess let's round off to maybe 1500. And let's have our x values go to, well, this goes to 100 here, so maybe we'll just go to 100. So let's adjust this so that our x-axis goes from, let's go a little bit negative, so maybe minus 25 to 100. Oops, this is minus 25. There's an extra one that popped up there, to 100. And then our y-axis, we don't have anything below this, so maybe we'll just go negative 100 just in case. Oops, the 109. And then we want to go as far as 1500 so that we can see a lot of these. Now, I guess we should go to 5000 if we really want to see, let's see. Then it gets kind of really small for that one point that we have, 4151, and actually that's 125, so I didn't even get that. 150 maybe. So here's that other point that we're missing. But let's say, well, I don't know if we care about that. Let's just keep our graph the way it is for right now. And so we have the 0, 0 graph, the 10, 185 graph, the 15. And if you look at the distances between them, they're not evenly spaced. But we still should be able to find the velocity or the area under the curve, estimate it. We can obtain an upper estimate of this by using the right-hand rule, but we'll see that in a minute. The interval begins at t is equal to 0 and ends at t is equal to 10. So the width here is 10 minus 0, and so that's equal to 10. So that's how wide this first interval is. The width is from the x-axis. The second interval starts at 10 and goes to 15, so its difference here, the width is only going to be 5. And if you look at the distance here in the graph between 10, 185 and 15, 319, the length there is going to be just 0.5 or 5. The final velocities in the two intervals respectively. And so the first interval here, the final velocity is 185. The second interval, the final velocity is 319. So let's get 185 and 319 here. And if we want to see that in the graph, the 185 and the 319, this is how the graph would look like. All right, let's keep going. So now we can calculate this So let's move this a little bit over so we can see it. So the first graph is going to be 185 with a base of 10. The next graph is going to be 319 with a base of 5. The next graph is also going to have a base of 5, but then the height now is going to be 447. And then the next one has a height of 742, but the width, what's the width going to be? The width is going to be, for this one, the width is going to be, let's take out the other one, whatever this distance is in the base. And how do we do that? That goes from 20 to, can't see it, oops, disappeared. It goes from 20 to 32. So it goes from 20 to 32. That's 20 to 32, or in a table, 20 to 32. And so we want to subtract that to find a difference, and the difference there is going to be 12. So for the next one, from 32 to 57, the difference was 27. And so the height that we're using for that, going from 32 to 59, the height we're using for that is 1325. So we're using 1325 for the height. And then we're using 1441 for the height, and we're looking at the distance between 62 and 59. And so that's a very small distance here between these two. And so the distance there is just going to be 3. Okay, so these are our values, and now we just want to multiply them all. So I wish we would have done this in Excel, but let's just take out our calculator and see if we can do this real quick. We have 185 times 10, and I'm not going to use parentheses. It might be good to use parentheses, but I know that the order of operation tells me that I'm going to compute my multiplication first before adding them up. So I'm confident that I don't need parentheses. So that's 319 times 5, and then 447 times 5, and then 742 times 12, and 1325 times 27, and then add the last one, 1445 times 3. Okay, so it looks like this rocket would have traveled 54,694 feet, 54,694, and I hope we did the arithmetic correctly. Yep, here we go. So that's how you would do this problem, and here's again some visuals to help us walk through that. All right, hope that helps.